Thank you and welcome. Thank you everybody for attending our discussion. I did just want to say briefly a few words about a couple of organizations that helped put this together. So I'm here on behalf of Space Force Association, which is the nonprofit which supports the U.S. Space Force. And of course, very interested in the topic of tactically responsive space. And then I'm also here, as she mentioned, as an adjunct faculty for Embry-Riddle Aeronautical University, where I teach in the Master of Space Operations and the Master of Science and Space Studies programs. And it is my great pleasure to welcome this fantastic panel. Let me figure out this clicker. So here we go. First, I'll introduce Eric Salwan. Eric is a new space advocate and entrepreneur. As one of the seed investors and first employee of Firefly Space Systems, Eric was a member of the initial team that worked to create an innovative small satellite launch solution. He has since led cross-department initiatives, including setting up Firefly's IT infrastructure, and he's now the Director of Commercial Business Development at Firefly Aerospace. Eric is responsible for developing the commercial business pipeline for Firefly's Alpha launch vehicle. Welcome, Eric.
Thanks. Great to be here. I appreciate the opportunity to come and talk about what Firefly is doing in the responsive space category. We have end-to-end mission solutions for responsive space. If you look at on-demand launch, Firefly has successfully demonstrated the ability to do a tactically responsive space launch. What that means is within 24 hours, we were able to do final orbital selection, get that programmed, do payload encapsulation, take the encapsulated payload to the launch site, integrate it with the vehicle, go vertical, fuel it, and be ready to launch within 24 hours. As soon as we got the go, we launched. That was the first time that's ever been done, and that was a U.S. Space Force launch called Victus Nox. That demonstrated a new capability for the United States of America, and it was really General Gutlein came to Firefly after that launch and thanked us for proving out that capability for the United States. We're also working on a deployable launch solution, so what we're going to be able to do is within 7 days deploy our Alpha to be launched from anywhere that we want to. And within 2 days of being on site, we're going to be able to be ready to launch. And we also have an in-space maneuverability solution called Elytra, and that is a high delta V maneuverable spacecraft. We can use that for our rendezvous and proximity operations. We can do it for space situational awareness. And we have that first one that is getting ready to fly. And that's very similar to our Blue Ghost lunar lander, which landed on the moon successfully earlier this year. Very similar components, so it's TRL-9 from all the way through cislunar space to landing on the moon.
Thank you. Next, I'd like to introduce Jeff Thornburg. Jeff is the CEO of Portal Space Systems, a next-generation spacecraft company redefining orbital maneuverability. He previously served as the Vice President of Propulsion at SpaceX, architecting the Raptor engine for Starship, and has held leadership roles at Amazon Kuiper, Stratolaunch, and Agility Robotics. He's a U.S. Air Force veteran. Thornburg contributed to the world's first hydrogen full-flow staged combustion cycle engine. Under his leadership, Portal closed one of the largest seed rounds in aerospace and is set to launch its first mission in 2026. His work has earned him awards from NASA and the Air Force, including NASA's Spaceflight Awareness Award. Welcome, Jeff.
Thank you, Sam. And I'd like to thank SFA and the IAC and the IAF and everyone for having us here today. It's a great honor and pleasure to be here with everybody. A little brief background on Supernova and Portal Space Systems. We're a Seattle-based company, Seattle, Washington. We're building Supernova, which is the world's first solar thermal-powered high delta V, high thrust spacecraft. It services multi-role missions for our defense and commercial partners. and with unparalleled mobility in a very, very rapid fashion that really hasn't been possible before. It's a 5 to 15-year spacecraft lifetime, and it's really designed for not just defense, but as I mentioned, commercial and government missions with NASA and others. The bottom line with what we're trying to build is we're really trying to solve kind of this age-old problem of spacecraft being designed to operate in one altitude and never go anywhere else. And so we're really the first transorbital platform where we can travel from MEO to LEO in hours, LEO to GEO in a day, LEO to lunar in less than 4 days. So we're really looking to provide that transorbital service in one platform and start to move away from all these bespoke spacecraft for every single mission, but really the iPhone of spacecraft platforms that can service multiple applications and missions for our customers. So it's an honor to represent my team of about 25 people at Portal. We've got 2 exciting missions coming up in 2026 for our risk reduction program, and we just expanded our facilities in Seattle as we start to manufacture these systems for our customers. So again, pleasure to be with you here today.
Thank you, Jeff. And finally, I'd like to introduce Luca Rossettini. Luca is a visionary entrepreneur seeking a profitable and sustainable expansion of humankind in space. In 2009, Luca won the Fulbright Scholarship, and in 2010 obtained a certificate in technology entrepreneurship in Silicon Valley, California. After an internship position at NASA Ames Research Center, Luca went back to Italy and founded D-Orbit, developing a solution for space logistics and transportation. Welcome, Luca.
Thank you. Thank you very much. It's an honor to be here in front of you, but especially to be part of this panel. You know, I really want to work with you guys as soon as possible. We were discussing about the lack of these services in the sector and the necessity of working in this direction. So what the Orbit does, we work on the space logistics, so the infrastructure that will enable all the future businesses in orbit and help the existing business satellite operators to do better and more profitably what they do today. Our goal is really to connect Mars, the asteroid belt, Moon, and Earth through a logistic network capable of transporting goods, that as we are doing around the Earth, people in the future, information as we are building around the Earth, and energy. That's something that we need to think about. 600 people, 21 space missions completed successfully, more than 200 payloads that we deliver in orbit. And since we started in Europe, and Europe, it's not Europe, but it's very fragmented, we have to become a global company as soon as possible. So you find many other locations there. I like to say that the orbit is where the best beaches on the planet are. So if you want to visit us, typically you have the sea or the lake close to you. Yeah. And that's it. So thank you.
Thank you, Luca. So this panel is meant to be kind of a conversation, and I'm told that they'll put up a QR code that will let you put questions into Slido, which will open up for questions a little bit later, but you can start submitting questions as we start the conversation. And for the rest of the time, this is the slide that you're going to be looking at. So I guess maybe we can start with you, Eric. If you could talk a little bit more about the importance of tactically responsive space missions as it relates to national security.
Sure. So tactically responsive space is critical going forward to national security. We were able to prove it out with our Victus Nox mission, and what that gives the United States the ability to do is to rapidly respond to any threat from our adversaries. So that could be a satellite that is we're deprived of that use to very quickly launch a replacement satellite. That could be in the event of a disaster. If we need to launch a satellite to have coverage of that area, we could do that within 24 hours of the call up as long as we're ready to go. And it also gives the ability as a deterrent for our adversary nations. If they know that we're able to very quickly replace these assets, it reduces their desire to take those assets out. And that's really what we want. It gives us a really great deterrent capability for the future of space missions.
Thank you. Thinking about, how you described it in national security from the U.S. standpoint, when we look more internationally, and I'll turn to Luca for this question, with international collaboration, how can allied nations and private companies work together to pursue, responsive goals without compromising things like, sovereignty and security?
Yeah, that's a very good and difficult questions, especially nowadays with the current geopolitical situation that is changing while we are talking, right? So, and new wars are starting everywhere, so defense is becoming key, and it's again entering the space. So defense created the space market as we know today, but now they are coming back with new ideas. So I think in the future, wars will be fought not using missiles, but using intelligence. So the space part, it's going to be key today and into the future. But in order to make it effective, then that's probably not possible to think that one nation alone can do it. Also because once you have an infrastructure in orbit, it's automatically covering the entire planet. So cooperation, I think it's a goal. It's not yet a fact. There are some cooperations existing among nations, but when you touch certain topics that are the more important, we are still lacking of a good communication flow. So I think the role of industries here, I think it's clear, because we need to cooperate. I need their services, right? So, and my customers, we are in 4 continents, so we have customers in 4 continents. So all of them need my services that I need someone else's services. So from a commercial perspective, we are already cooperating. How we help the defense to go into pursuing their objectives, but also into these cooperations, I think that's a responsibility that we have to take as industries as well.
I guess if I could jump in there, I would say space is not about the cool Star Trek, Star Wars tech. It's about information dominance when it comes to defense applications. And so the international cooperation is critical in that to counter our adversaries, the allies must have the information dominance, and the only way that happens is through interoperability, as well as the ability to work together to firm our network together to have that information superiority. That's what everybody's chasing. That's why space is so key going forward. And I would add to something Eric said earlier, where it's not just rapid launch, but it's also how do you move assets rapidly on orbit as well. So it's going to be a combination in dynamic space operations and tactically responsive space to have both rapid launch as well as rapid movement of existing assets on orbit as well.
What about the regulatory kind of policy aspects of that? Is there things from like navigation or perhaps keep out zones and transparency with other governments? How do we handle these kind of issues?
I love that question because it kind of falls under this vernacular that the industry likes to use called space traffic management. And if you're a pilot or you've ever seen an aviation map, you have these, what's called an ADIZ or a keep out zone for around a military base or some sovereign border of a country. That's not how space works. Everything circles the globe at rapid speed. You don't just carve out a thing over the top of your country and say nobody can enter there. That's not how it works. And so I think the cool part of your question is, regardless of whether you're friendly or adversarial on orbit, you have to know where each other are. And if we don't have a system that tells each other where we're at, then you're guaranteed to have conjunctive events, and that's just engineering speak for running into each other, creating debris, and causing problems. So just one person's opinion here, but regardless of adversary or friendly, we must come up with a global strategy for space traffic management for both peacetime and when it's not peacetime, in my opinion. And I don't think, Sam, we have that problem solved. I think the ISAC is a great start in terms of information sharing among nations, but it's not adequate for who is going to be the arbiter of truth on where things are and how they're moving. We do not have air traffic control or international air traffic control for space, and we need it to happen very, very quickly.
Luca?
Totally agree. So that's a good example where we need cooperations, right? So I give you this example. I think a couple of years ago, we did a rendezvous with the commercial satellites from a US company, private company, right? So we did it well. The US Air Force was involved, and ESOC in Europe, they were involved. They helped us. They said, don't go beyond 1 kilometer. So we stopped at like 800 meters. So we were everything okay. And then the other way around, now they want to do a rendezvous on one of my satellites. And then the State Department in US contacted my government in Europe, and they were, oh, whoa, what's going on here? So how comes that in 2025, then we are talking about rendezvous docking, orbital maneuvers since like decades, and how comes there are no yet agreements or like rules of like procedures to follow, right? So we are setting the directions, but I don't think it's correct to leave the companies alone in this path. So, and as you said, it's like European company with American company, maybe tomorrow there will be a South of America or maybe an African company. So, and that's something that we need to take into consideration.
And I think it's driven by the fact that the governments of the world, and it took sovereign financing to go to space. And now the commercial space industry actually operates more spacecraft on orbit than any nation. But the nation's rules and regulations for stuff like this have not caught up with the reality of commercial space operators are now the dominant players on orbit. So how are we going to address that? We need the governments to catch up with where we are from a technology and commercial space standpoint.
Thank you. I do have a question that came from the audience now, and maybe Eric can take a crack at this. Does tactically responsive space also include delivery of cargo via rocket to destinations on the Earth?
So currently, we're not doing that, but the U.S. government has started investigating those programs. And in the future, I think we are going to be able to see that. So technically, using a rocket, you can deliver cargo anywhere on the Earth within about an hour from launch. So there have been some early investigations of that, and I think we're going to see that. I think there's some complications with that because once you land that rocket, to actually get it back, you're going to have to refuel it, you're going to have to reboost it. So it's going to be a complex problem, but it is an interesting problem that I think we're going to see a lot more development of in the future.
Interesting. Thank you. Maybe turning back to Luca, what does sustainable space, resilient Earth mean to you?
Well, sustainability we started a company with this in mind. I think it's an obvious necessity. So if we don't create a sustainable space, there will be no market for anyone, not for the defense, not for us. And again, like talking about tactical responsive space, we need to be very careful on how we manage space. If we do something on Earth, typically you have a restricted area that is impacted. But when we do something in space, the entire space is impacted. So, and that's something that we need to take into consideration. So that's why I said, bringing missiles in orbit, guys, it's not a very good idea, right? Because it's a lose-lose. I do remember there was the movie War Games in the 1984. Probably half of the audience, they don't even know what it is, that movie. But at the end...
Do you want to play a game?
Exactly, right? So at the end, the computer, the AI ante litteram, understood that it was a lose-lose, right? So, and like missiles in orbit, it's a lose-lose. We lose everyone. But on the other hand, you want a resilience. So so that's something that in space, it's still, I think, at the early stage. How can we protect our assets? How can we make our assets durable? And how can we make sure that our assets is not hackerable? So there are three different aspects. Cybersecurity is the last one. Durable means certain type of quality that match with the speed that you need to have, so the responsiveness. And the first one is how we protect, how we manage the threat. Not just debris, of course, nowadays, right? So these are the three elements that I think is going to be very rapidly developed in the next months or few years.
Yeah, and if I can just branch onto that a little bit, when we talk about the deterrent capability of responsive space, one of the things that we're trying to avoid are these, if you look at these previous ASAT tests that have been done to take out a satellite on orbit, they end up creating debris clouds. So what we're very much trying to avoid is kinetic attacks against on-orbit assets that create those debris clouds. And by having a responsive space capability, you then deter people from actually launching those attacks and then further polluting the space environment.
Interesting.
Yeah, I don't think most people realize that those types of events, when you create those debris clouds, will basically encircle the Earth in whatever orbit they're in a matter of hours, which means anything in that orbital track is now susceptible to damage or destruction. And all it's going to take is a few of those types of events to deny access to everybody to that particular location. So it's a serious matter that's got to get addressed.
There's another interesting question which kind of branches off from what you were talking about, and I'll give this one to Jeff. What kind of communications architecture will be needed to make tactically responsive space work? And do we have the right C2 infrastructure today to make this work in time and in space?
I think it depends on what kind of mission you're talking about. I mean, as far as what kind of communications are required, obviously there's a tremendous advancement in optical communication with OASL, optical satellite links, as well as OCT terminals on orbit. I think when you talk about how allied nations work with each other, the communications question as asked, I would say we have to develop standards in which we can have the interoperability with other nations and make that communication very easy. In terms of orbit to ground, I don't think the ground station problem is going away. I mean, we definitely need, continual and persistent ground communication as they're available, but that's costly and takes time. And then that communication also has to be protected. And I think there's some interesting technologies. If you let me stretch a little bit into the future, quantum is around the corner. And I think the race for quantum technology is real. And the first to have access to true quantum encryption and decryption are really going to own the communication conduits and back to the information dominance we talked about before. So you either need to be quantum resistant, meaning people can't crack your communications, or I think we could find ourselves in a few years in a situation where the entity that owns the ability to master quantum, there is no encryption capability that's going to keep people from owning communication and understanding everybody else's as well. So I think those are the types of things that come to mind when I'm asked the question about what kind of communication and ground C2 infrastructure needs are going to be needed for anybody, especially the allied nations of the world.
Yeah, so if I may add, there are two sides. One is getting to where you need to be in orbit as soon as possible, exactly where you need to be, right? So that's rapid response. The other side is to get the right information, not the data, but the right information exactly to the man on the field, or maybe not even to the man anymore, to the machine that needs to go somewhere. Right? So exactly where you need to be. So in this sense, now we are still thinking that we need to enlarge and enlarge and enlarge the bandwidth. But in reality, what do we do on Earth? We use a cloud computing systems that actually do all the processes. This is happening in space. We are not the only one, by the way. So we have 4 nodes, but there are other companies that are doing the same. We demonstrated that you can reduce the amount of data that you typically need to deliver by 98% to have exactly the same information. That means that you can reduce to seconds what takes hours now to get. And from defense, that means that you can have a man with a portable antenna, he can receive the GPS coordinate where to go, or just communicate with the truck to deliver the water on the field where it's needed. So it's still at a very early stage. There are many, many companies worldwide that are working on that. That's a clear example. So this cloud infrastructure cannot be a monopoly. It should be a distributed cloud infrastructure. Because let's be honest, we will never be able to have the same cloud power that we have on ground. So we need to connect all the we need to create satellites that are cloud ready in order to do it. At that point, the hackerability is going to be still possible, but more difficult because you don't know where the information is. But you can get the information exactly where you need it because you have always some satellites in visibility.
I'd also like to see us move away from, you are going to see the push to autonomy, which is going to negate the need to have as much ground C2 and communication infrastructure, because the time it takes, when we talk about tactically responsive space activities, the defense ministries of the world need to make decisions in seconds and minutes. So we can't have communication happening between ground and spacecraft. By the time you understand what's happening and make decisions, it's over, whatever's going on. And so AI and ML as applied to autonomy on orbit will start to supersede more and more ground C2 and communication, because that's what's going to be required just based on how quickly we're advancing technology on orbit right now.
What about non-military applications? Are there civilian commercial applications for these tactically responsive capabilities?
Yeah, for sure. And we've already started talking to customers about this. If you look at some of these satellite constellations, they might have these very expensive on-orbit spares that they have on orbit in the event that one of their satellites goes out. They can quickly replace that capability. Well, instead of doing that, you can have ground spares and you can have a responsive launch capability so that if you lose a satellite in orbit, you can quickly replace that exact satellite at the right spot, and you don't have to have a bunch of on-orbit spares to augment one of the planes. At the same way you can do that, instead of having these on-orbit spares up there for years at a time, and that technology is getting stale, you can replace the ground spares on a regular basis. So when you have to replace that orbital satellite that's failed with the rapid response capability, you're doing it with a satellite that is up to date with the latest technology.
Yeah, I guess kind of as an adder to what Eric said is, I agree we don't want to have a bunch of on-orbit spares that can only do one thing, which is why we're approaching the problem a little bit differently, where we have a multi-role application where we have multiple capabilities on Supernova so that we can be performing commercial missions or defense missions, and then we could actually move into supporting a need that developed where somebody has an asset that's now not working properly or is inoperable for some reason. And that's why it's so important to be able to move those assets within hours to accommodate whatever the need is. And it doesn't have to be defense, to your question, because time is money on orbit, and these constellations are the currency is data, and every minute that they're not selling data, they've got a revenue problem. And so the faster we can fill that void, the better it is for commercial operators as well. And so I think it's just as important on the commercial operator side on how we support it with rapid launch or rapid maneuver from spacecraft as it is on orbit and in orbit quick maneuverability applications. I think it helps both.
Think about natural disasters. So fast response means saving lives. So if it happens that you have a thermal infrared cameras, you can detect fires. Maybe you are in the wrong orbit, but with these capabilities, you just move into the right orbit. What standard satellites cannot do, right? So that's the new capabilities that we see in space more and more nowadays.
One other I thought of real quickly, because I saw a colleague in the audience, is the number of maneuvers these massive satellite constellations have to do to get out of the way of orbital debris is money. And so every minute you're dodging stuff is a minute you're not operating for either your defense or commercial application. So having on-orbit servicing capability to pick up this debris and get it out of the way is saving a tremendous amount of time and pain and dollars commercially. And that business case is real right now. We're not waiting for that to happen. But I think a lot of people hoped the debris thing, while we're talking about commercial, would be supported by governments of the world, enforcing rules that said, if you litter on orbit, there will be a financial penalty, which would drive a business model. That hasn't happened. Instead, what's happening is the massive LEO constellations for mostly broadband internet providers have so many assets and now are moving so much, it's costing them significant dollars to do that. And now there's a business case for that commercial application for servicing on orbit and being able to rapidly move and clean up that problem. There's a real business case for now.
Interesting. What about, this is one that came from the audience as well. We're here in Australia for IAC. And what role, if any, does Australia take part in tactically responsive space missions How would you like to see Australia take part, keeping in mind that Australia does not yet have a launch capability?
I'd love to jump in on that one because I've had the good fortune to not only interact with a lot of amazing Australian companies this week, but I've had the privilege to work with Australian civil servants within the DoD as well as the military. And I would answer that question by saying it's already happening. Australia is one of the closest allies with the U.S. That there is, and they've played a huge part in the defense of the allied nations for many, many years, and in space since, I think, 1960. And so I think the intelligence relationship those two countries have, the military alliance that exists there is super strong. I think the up-and-coming thing is there's an ecosystem in space growing here that I'm really excited about. It's one of the reasons I wanted to be here this week, to explore partnership opportunities. And so I think I want to see more of those commercial partnerships between the U.S. and Australia, the growing military relationship and the continuation of what's been established for many decades, and then expanding upon some of the great opportunities that exist across Australia in ground tracking, ground stations, communication operations, remote operations. I think there's a tremendous amount of opportunity here that I'm personally excited about in the future.
Yeah, and I will say I am too, and I've gotten the opportunity to talk with multiple of the potential Australian launch sites, and it is going to happen. I mean, there's really good locations in Australia to do a domestic launch site, and when you combine that with the deployable launch solution that Firefly is working on, you can quickly get one of those launch sites up and active. And one of the concerns just in general that the United States has is diversity of launch sites. So if there's some sort of instance where we're deprived of one of our launch sites in the United States, having the ability to launch from Australia, which is a very close partner with the United States, is going to be a huge asset.
What about Luca? What's your view coming from Europe on these kind of things?
I don't see any difference. Why Australia should be treated different? And if we talk about launching capabilities, who has launch capabilities nowadays? China, United States, Europe, India, Japan, Russia. But we have almost 200 nations on this planet, so that's not a key aspect. And by the way, I think Australia has some launch capabilities already, at least to orbit, at least once. So it's already happening, and the launch site it has been created with a lot of difficulties, to my knowledge, but it's there. So it's just a matter of time and cooperation. There's something that Australia do better, and then we should leverage on them, and some that maybe is still missing, and then you can cooperate with other companies in order to fill the gaps. But at the end, we are talking about a nation that it's close to the United States, but it's close to Europe as well, and it's on the other side of the equator that I think it's something unique and like an advantage, a competitive advantage.
Eric, what do you think is the biggest barrier for tactically responsive space missions to go from demonstrations to full operations?
Yes, I think we've already demonstrated commercially that we can do a responsive launch with the Victus Nox mission. I talked about that from call up to preparing to launch in less than 24 hours. One of the big things that we do have to work on is regulation. So we have to get FAA, FCC, Space Force to work together to really streamline the regulations that will allow for responsive space missions. And I think that is happening. People see the need for that. And I think we're going to see improvements in that in the future. We have 2 more responsive launches that are coming up. We have Victus Haze and Victus Sol that are both under contract that we're going to see. So we could see that this is an emerging segment that is just going to continue to grow, and we need to have regulations that match that.
If I may add, so I think that even in this case, 2 aspects. One is that if, let's say, a defense customer in this case, right? So they are used to buy assets. This is something new. What we are talking about, it's like tactically responsive space is something new. So even if you sell the assets, then you need to transfer some knowledge. And that's still part of the procurement process that it's not entirely done. So it's work in progress. They are working with companies and so on. On the other end, you can provide a service. So you can buy a service from companies, but then again, you enter into a domain of a different type of procurement methodology. So United States is definitely more advanced, but not as advanced as everybody thinks. It's not you go there, you have a service, and then defense buy from you. It takes a long time. And they are typically used to work with like companies that they were working with them since many years, and that's normal and natural because that's a matter of trust. We are talking about security. You want to work with someone that you trust, right? So these are barriers that are lowering down, but if we really want the like responsive world to be real, then we need to accelerate these lowering down these barriers because we have the innovative services, but then we need someone to understand. Just to give an example, if I sell services, let's say that we are so good that all the procurements of the defense and civil change and they can buy very easily services, then there is another issue, the financial aspect, because to sell service, I start making money when my asset is in orbit, while I have to spend money like probably 1 year before. Right, to procure all the parts and start manufacturing and so on. So how can I make sure that they have the financial stability to like prepare 1, 2, 3, 10, 100 assets in order to deliver the service that is required? So there is also these aspects that need to be taken into consideration. It's not just procurement, but it's an overall comprehensive view of this new way of providing services.
We definitely have more affordable launch than we ever have had in human history. But I think when you talk about tactically responsive or dynamic space operations and those types of buzzwords, it comes down to, do you have the right assets on orbit or in the hangar ready to launch? And so for any nation or set of nations, I think the bottom line is it's not just having affordable launch, but you need enough launch and you need enough assets so that you can quickly get information, and we're not there yet. We don't have enough of the right assets in all orbits and all locations to have immediate access to information. Anytime a natural disaster occurs, you still typically are moving an asset, and that takes time. So that means people are under threat of death or injury because of the time it takes to move these assets to get data. In defense and wartime scenarios, same thing. It takes time to move assets, which means you lack information, which means lives are on the line. So I think the push really is, this isn't some magical wand scenario where you wave it and magic appears and you have tactically responsive space. It's what are the assets and how can they communicate through our allied work together so we can have immediate information on any scenario that pops up. That's really what we're trying to chase here as a part of either defense or commercial applications.
Thank you. We do have a couple of minutes left, and I want to pose a question for each of you to answer. Since the three of you have all been founders of successful space companies, and maybe we'll start on the other side this time and work this way. Do you have one piece of advice that comes to mind? Because I'm sure there's a lot of space entrepreneurs out in the audience to give them a lesson learned from your arsenal, let's say, and we'll start with Luca.
So it's going to be a long journey, guys. A lot of sweat and blood, so be prepared, but don't give up because the market is growing so fast and it's so logical that it's going to be bigger and bigger that if you don't give up, you have the right idea, the right mentality, you preserve cash as much as possible, then you will be successful. So don't give up.
Yeah, that's very similar to my thought as Sam asked the question, but it's true. It's one of the most difficult technologies and industries that you can be an entrepreneur in. And like I tell founders all the time, I think a lot of engineers think, if I'm smart enough, I can solve all the problems on my own, because that's how engineers like to think. But in space and the space industry, it takes a talented team basically grinding it out every day in the face of adversity, because there's a lot more entities and people and organizations that want to tell you you can't do something than ones that will tell you you can. And so you have to believe in yourself, you have to have a strong team, and you have to ignore the naysayers and keep plowing forward. And it just takes time. And I think a lot of people sometimes think that company got lucky or that founder or CEO got lucky. Those people didn't get lucky. They kept grinding, and that's what was the secret until they reached the level of success that they had.
Both of you just gave some incredibly good advice. I'm going to say, without resilience, you're just not going to get there. I mean, you could look at the story of Firefly. There was a lot of things that went wrong. We had an incredible team, and when things went wrong, that team got together and they figured out a solution, and they went out and they implemented that solution. You cannot get from the concept and the vision to landing on the moon and expect it to go smoothly, because it absolutely didn't. So you have to surround yourself with people that have a desire to succeed. You have to go out and you have to, I will say, and this is very true, it can't just be engineers. You have to go out there and you have to create a network of people that believe in your vision and that are going to help you. Some of the people, some of the friends that we made in the process of Firefly, they showed up at the exact right time, and they gave us help that was beyond anything that we could have expected. And without that help, we wouldn't have been able to do it. So you got to go out there and you got to make some friends.
Thank you, all three of you, for your insights into tactically responsive space. And thank you to the audience for a lot of the great questions that were asked throughout the session. Appreciate it.
Thank you.
Thank you.